Hi, everyone. My name is Shylo. You might know me as LT Snake Plissken. And yeah, I'm here with Ball as well.
Hi guys.
And so today we're talking a little bit about bridging as a service. So you might have heard a little bit about us if you're here. You might have been following us kind of through our journey. So briefly, a little bit of history on Elk. We started back in 2021. That would be March 2021. On the Avalanche blockchain, where we call home. So today we're talking a little bit about, uniting Avalanche Subnets, connecting other various blockchains. So yeah, we're going to go over just how that might look, some aspirations for the future, and yeah, kind of jump right in. We've only got 30 minutes here, so I'll try to get through as much as I can. All right. Perfect. So yeah, I'll let Ball take over, explaining a little bit about subnets.
Oh, I have. Okay. Yeah. Okay, good. So, guys, I didn't know anything about the presentation before like 5 minutes ago. So, yeah, basically, what are subnets? I think Imin explained that before. It's a way for any developer to essentially scale their application to run in their own dedicated sub blockchain, which is governed by Avalanche. Yeah, I mean the benefits of that are obviously scalability. You can also control, your own token, which would be used as a gas there, and you can do pretty much whatever you'd want in terms of setting up your own rules, governance, and whatnot. You'd have your own validators. So, yeah, subnets are something that we've been looking at for a long time. We initially did not set out to specifically target subnets at Elk, but we have kept a pretty close interest in them. And yeah, I mean, I guess we'll be talking a little bit about how they fit within the entire Elk ecosystem and how we plan to help subnets achieve cross-chain communication in the future.
Yeah, so I think one of the things that's missing for a lot of subnet, a lot of Avalanche subnets, is basically the connection between. So that messaging layer, so that one subnet knows what the other is doing, and the problem is quite similar when we look at individual blockchain. They're siloed. So they cannot easily pass messages from one to another. So that's where there are a few solutions here and there, but this is kind of where Elk's bridging as a service comes in, which we're building towards a decentralized messaging layer that eventually is somewhat of a roll up for any different chain that it's connected to. So that's kind of the problem that we aim to solve. Basically, subnets can benefit. One can know what the other is doing. And not only that, you can think of this as bridging, right? Moving tokens from one blockchain to another, which we see kind of many options, because I think the future is certainly, composed of multiple chains, and I think subnets are a step in the right direction there, because you remove a barrier. Because running an archive node for an entire large blockchain, such as something like Ethereum, ends up somewhat centralizing the operation of the blockchain because of the large expense and requirements it takes to set up such a large blockchain. Just who has that many petabytes or terabytes, multiple terabytes, hundreds to store a full archive node and kind of run through that. So with subnets, you've kind of got that part and parceled out for its own specific purpose. So then what we're doing is connecting those together, as we go. So, all right. And that was the slide I should have switched to. All right. So, yeah, we aim to have a pretty easy connection process between, you know, different blockchains, different subnets, eventually utilizing a UI to do so. Now, the most traditional use case you would see with this is simple bridging. Using the ElkNet to simply take a token from chain A or subnet A and basically, you know, put it in a reservoir in chain or subnet A, and then receive it from a reservoir on subnet B or even a chain B or chain A. So subnet to chain, subnet to subnet, it can kind of look like a variety of different things. You know, so that's kind of the basic one. But today we're looking at showing more of a little bit of a demo of a cross-chain swap. You know, so I'll get into that in just a second here. But the amount of things you can do with cross-chain messaging is kind of almost infinite. You could do things such as, you know, send an NFT on one chain, which triggers an action to perform another you know, operation on the destination chain, right? So you could, let's say, send in an NFT on one, and then get tokens on the other, or you know, you could use it to, you know, facilitate, you know, Web 2 to Web 3, you know, transactions. Something could happen somewhere and it triggers something somewhere else. So really, the possibilities are quite endless. Yeah, so I'm going to go over a little bit of a demo of what that might look like. But before I do you have any comments on anything?
Oh, yeah. Just really, I just wanted to make sure that everything was clear. It might not be 100% from the slides. So we've got two components that we're talking about here. One is the ElkNet. This is this essentially messaging layer that connects different chains. And this is general purpose. It basically can connect to arbitrary chains, and we support arbitrary messaging protocol, arbitrary attestations, and all of that. Now, the piece that we're really talking about here is not so much this core infrastructure. We're really talking about this bridge as a service, which is more targeted at developers. Of course, developers are welcome to use the ElkNet directly, but presumably for, let's say, most application use cases, you don't actually want that. You simply want to, you know, implement some custom bridging logic. And so this is what BAS is for, right? So BAS is a set of APIs and contracts that make it really easy for any developers to implement any kind of custom behavior that they'd like to see in their bridge. And they can customize this at will, all sort of under that umbrella BAS, which is pretty much an SDK at this point, and which we are currently testing in alpha, and we'll be moving to beta probably sometime in June or July. And the point of this really is to make things as simple as possible for developers. And yeah, I mean, so this is really what we're talking about. This is what we are looking to present today, and this is what the demo that we're showing you, well, it's just going to be the UI essentially, but like this is what the demo that we're showing you today would basically be using, and is currently using on alpha. And the amount of code that is required in order to do this is actually really limited. So you basically need just a few clicks, a few lines of code. And here you go, you have your own bridge and you can kind of do whatever you want with it. So yeah, I mean, I'll just let you take it away with the demo. And yeah, if there are any questions, let us know after that. Thanks.
Yeah. Awesome. Thanks, Paul. Okay, so just switching here to the demo. All right. So could be as simple. So in this example, we're connecting, you know, what are effectively multiple chains together. So in this example, you'd have a token bridge that you'd choose what chains you'd want to connect to, what subnets, and after making that choice, you'd simply click next. In this example, I mentioned we were talking about cross-chain swaps. So you could have a pair of tokens on either chain. Let's say, okay, you had a pair between AVAX and Shylo, let's say, on, let's say, one of your Avalanche subnets. And you had a pair for, you know, Avalanche and ETH as well on a different subnet. And once you've added all the pairs that you need, you would kind of continue. You'd also be able to set a specific fee for your BAS that users would supplement so that they, you know, could, you know, profit or send to their users or kind of whatever they're doing. And within this as well, there'll be ability to customize finality, meaning how many confirmations within reason it takes on the origin chain before the deposit is released or the action is taken on the destination blockchain. So that will influence speed, and so projects will be able to decide their security to speed ratio, because you can't have full speed with full security, so there's always a little bit of a trade-off there, but builders will be able to customize that. You know, so of course that would be created within custom settings here. And they would simply proceed. It would, you know, link whatever chains, whatever subnets. You could link a subnet with a chain with a subnet, and bridges will go both ways, so back and forth. So it's not like we're building, you know, in this case, one bridge from Avalanche to Shylo, and then another bridge from Avalanche to ZK Sync, and then another bridge from ZK Sync to Avalanche. It's actually just one bridge because it all goes through ElkNet, which eventually will be kind of as trustless as possible, being secured by node runners who are staking the Elk token. So users would be able to builders would be able to set this up, kind of confirm it and deploy, and yeah, would be able to do that. Have a unique identifier for their bridge, their realm ID, yeah, that's kind of what that might look like. A little bit of a kind of hands-on demo. So yeah, I hope that was semi-clear. That's why we have, you know, our conclusion slide here. So feel free to, you know, ask any questions that you had, yeah, I'll open that up. Mm-hmm.
Yeah, so essentially this is exactly what's happening, right? So it's deploying the different contracts on the different chains, which you control, which then essentially can be operated. The deployer, yeah. Yeah, so if you use the BAS as it currently is, you would not be able to do that, at least not easily, right? Because those contracts are essentially written with that in mind. So like with sort of making it as secure as possible. But if you just customize the code yourself, then yeah, you can pretty much do anything, right? So like we're not here to sort of enforce any kind of behavior. The bridge that is deployed by the developer is essentially up to the developer to protect beyond, you know, simple beyond basically the protection that's afforded by ElkNet in terms of operating the bridge, right? So like if you deploy this with wrap tokens, and the developer is malicious, then yeah, the developer could essentially steal those tokens, and there wouldn't be much we could do about that.
Where does ElkNet come in that example where you're actually deploying the two contracts?
So at the point of deployment, it doesn't come in. At the point of use, it comes in, right? So if someone then uses that bridge to move tokens around, then the messages that need to be sent across the different chains or different subnets can be sent by ElkNet. It's not actually a requirement that they be sent by ElkNet. They can also be sent by some other messaging layer that works cross-chain.
And of course, it would be really clear from the code, you know, if a developer were to alter some of those constructors to be malicious. So that would be quite, I think, apparent. It wouldn't be allowed with the default configuration. So it would be easy to catch for us to decide what for the user or anyone to see what's whitelisted in that case, right? How much does it differ from the set out code, right?
Yeah, I mean, pretty much, you know, same security model as a smart contract, right? If the owner of a smart contract is in full control and can act maliciously, then obviously the owner of a smart contract for a bridge can also act maliciously, right?
Thanks. And ElkNet is a blockchain, or what is ElkNet?
So currently it's not a blockchain. Currently it's a peer-to-peer network, which is secured by multi-party computation and TSS signatures. Eventually it will be a kind of blockchain, but right now it's not.
Okay.
Well, thanks for all the questions. It's great. Anybody else have any questions or comments? Compliments? No? Insults? Insults, yeah. All right. So I'd like to invite everyone to, if they'd like to test the bridging as a service, I've got a QR code here for a little bit of a Google form to fill out, and you can use access code 42 to when the form asks, and we can get you signed up to be a tester and give it a whirl. We've also got some free coasters if anyone wants. So come see me afterwards.